Okay, hello, welcome everyone to this YouTube video. In the last video, we sort of have our Minder mind map as such. We have implementations of iComponent in iPi, iPalm, iHeater, iCooler, iHeat Exchanger. So it's just a way for me to map the inputs, outputs, what the code structure should be like. If it makes sense to you in Minder, hopefully it translates to a very neat and tidy code later on. Okay, without actually starting your coding. So this is the planning part. Okay, first thing I want to change, maybe this should not be an implementation here. Okay, iComponent may, instead of being implemented by iPipe, iPalm, and whatever underlying code, okay, I mean these are of course interfaces, right? These are interfaces I want to have. So maybe I'll just call it inherit. Okay. Oh, let's see. I wonder if there are arrow keys that can make it move around. But anyway, these things should be maybe inherited by interfaces. Okay. Or maybe, yeah, this part will be the, maybe I'll do later. I'm still figuring it out, how best to arrange. If not, yeah, if it doesn't work well, then yeah, we'll try to redo a mind map later on. Okay. Right, let's see this implementations. Okay, so the underlying implementation code can be using any one of these interfaces. Maybe using a class that selects a class that selects what do you call that? A class that selects which component to use. Yeah, I think that's maybe I should have a component selector class which actually does a component selection. If you know what I mean. Yeah. Okay, but anyway, I'll have to redesign the earlier part. Okay, maybe I'll do that. Yeah, I'll do that now. Okay, the input for sure, you want to have a component type. Okay, you need to specify to this component what kind of a component you want to have. Maybe it will use a enumerated list, enum list of components. Okay, so the user must specify what kind of component. Okay, you have to select from. You select from some enumerated list of components, which makes sense because from our ASP.NET call, we can actually select from a drop-down list, and I want to use that drop-down list to do something. Okay, so this will constitute the inputs and the outputs. Implementations, I guess once you select all of these, you will know which class to take in. Okay, so if it's a pipe class, you'll be using the pipe interface. All right. Yeah. I think I will still. Let's see. Let's see whether I can change the nodes. Yeah, there's a lot of things you can do with this. It's like a add connection, add group. Yeah, I can connect these two together because they are linked ideas. If they are linked ideas, okay. Okay. Maybe I'll call this dependencies instead of implementation. Okay. Okay. iComponent implementation. It should be something else. Oops. I'll put it here maybe as implementation. Okay. Maybe a simple component class. Okay. And then I'll just put the purpose of this simple component class here. Okay, what is it here to do? Select components, and that's all it does. Users Yeah, I'll just put some ideas to jot down here first. It'll be very messy, but maybe I'll tidy up later. Okay, simple component class will use, let's see, we'll use, let me think. Yeah, use dependency injection to obtain right component. Maybe something like that, I don't know. Okay, let's see. Okay. So what other kind of inputs? Maybe you can have an operation mode. Okay. Why am I putting this operation mode here? Because there are so many ways we can operate a pump based on all of this: delta P, pump curve, energy stream, etc., etc. Okay. I really don't know how this whole thing is going to pan out, but it seems over here it's very difficult for the user to actually put in so much data at one go. Okay. Okay, maybe I'll do the user interface part later. Anyway, yeah, maybe it doesn't make sense to put all the input types here. Okay, I think the operation mode thing should still be put into this iPump iPipe interface. Okay, operation mode. Operation mode is that how do you what kind of thing do you want to select? Okay, I think yeah, let me think. Okay, I think I know what to do. This should be actually dependencies. Alright, so I will have, okay, let me have a implementation first. Okay, what is this implementation supposed to do? Pump selector. Okay, so this pump selector class will implement iPump, and or maybe pump selector. Yeah, pump selector will implement the iPump class. Okay. Okay, and what it's supposed to do is to select. Okay, I'll just put the purpose here. Select calculation algorithm. Okay, so yeah, this will implement the iPump class, which you have to input the operation mode, and based on that operation mode, the pump selector will actually figure out which of these classes to actually use or which constructor to run. Okay, I guess that's one way of doing it. Okay, I don't know whether this will work, but that's just something I have at the moment, so just live with it for the time being. Okay, right, I think let's keep going to the right. Okay, let's keep going to the right. Then we can yeah, it's easier to use the touchpad on this one, right? Yeah, it's easier to use a touchpad. Okay, so as we go to the right, we'll see what delta P, pump curve, all these actually depend on. Okay, these dependencies are classes that will do concrete calculations, but they'll need to depend on some kind of interfaces. Okay, and let's see. Yeah, this dependency should be put into the pump selector instead. So I'll just cut this. And let's see whether you can paste it here. Oh, so good, so good. Okay, Now I know how to do it. So yeah, I'll just copy and paste, cut and paste the dependencies here. Okay, dependencies will be pump delta p, pump curve, all of these things. These will be solid dependencies. I mean concrete implementations. Tightly coupled, I guess. Yeah, actually, when it talks about dependencies, I should put a interface here. Okay. So implementations. So let me put a dependency. C's, and then I'll put a pump calculator. Okay, pump calculator. This will be implemented by all of these interfaces right here. Okay, so how yeah, dependency should always be, you should always be dependent on an interface. An interface will have several implementations. Yeah, pump calculator will be put in, and based on what kind of calculation algorithm you select, the constructor injection will then be, or the constructor will then be different. Then you can sort of just add, okay, and that will be sort of a case structure thing. Okay, I don't know how to make it even more simple. I may be designing it wrong, but hopefully it's okay. But yeah, let's keep going to the right. Okay, let's say I want a simple way of looking at this pump delta p. Yeah, it is just taking an input and an output, right? It will be dependent. It will be the idea is therefore. Okay, all right. Let me put inputs and outputs, yeah, on the pump. Okay. What's a pump calculator supposed to do? It's supposed to take some input. What kind of input should it take? Okay, for sure we want yeah, we'll want to do something. Maybe inlet temperature here, pump temperature, or inlet pressure, inlet flow rate. Okay, output will be outlet pressure, outlet temperature, outlet flow rate. Okay, regardless of whichever calculation algorithm we use, all of these can be our inputs and outputs. Alright, in fact there can just be some sort of properties here. Yeah, we can even invert it, but I guess next time we can do that. Now it doesn't make sense to change the yeah, it doesn't make sense to calculate inputs based on outputs. I don't want to do a back calculation way. I want to do a forward calculation way only. Okay. If there's a need to extend it, probably I'll make another fresh interface and some dependencies on it. Okay. Let me think. Alright, anyway, so this is the pump calculator. Its job is to take in the inlet variables, and then it's supposed to give you the outlet variables. Okay, that's its job. Okay, and yeah, eventually you should use it to calculate the outlet material stream temperature, pressure, flow rate, etc. Okay. Yes, so based on this inlet temperature, pressure, flow rates, you'll have to of course specify units. We'll just use SI for the time being. Okay, yeah, let's see what else is dependent on. Okay, so it's a pump class here. Pump class here with so many public properties that should not be here. Again, it should be segregated. Okay, so this is a calculate thing. Yes, enthalpy, blah blah blah. This should be inside the code. Okay, so let's see. Let's take a look at one of these things. This is a curve calculation mode, which is more complex. This one is simpler. It talks about energy stream. Okay. Yeah. Or maybe based on pump power. Yeah, calculation mode is power. Okay, so there's some TMP as iFlash calculation result. This is an interface. Okay, so we make we calculate based on enthalpy. You see, there's an inlet and an outlet enthalpy, and an efficiency value. Okay, an efficiency value. Okay, yeah, efficiency value. Then calculate an outlet enthalpy and calculate outlet pressure. There's a lot of debug modes here, and then we finish. Okay, this is actually pretty straightforward. Okay, based on the power. Based on the power, you kind of multiply into the efficiency, and then you add it to the enthalpy bit. Yeah. Ooh. I don't even know what this WI thing here is. Okay, but let's see. Yeah, let's see what this WI thing is here. I have no idea what that. Or maybe let me take a look if there's this thing called dim WI or WI. Okay, WI is a double here. WI here, oh, this is a mass flow rate. Okay, you have to have a mass flow rate here. That explains a lot. Okay, so we do have a WI here is mass flow rate, but it's very hard to read here if everything is defined on top, and you have to go and look at it one at a time at the bottom. Okay, so this is okay. The enthalpy is it is the energy input that you kind of have to divide by. You multiply by some of the efficiency values and divide by the mass flow rate so that you get the outlet enthalpy. This is what this part is doing, and of course yeah. Of course, based on the outlet enthalpy, you try and get the outlet pressure. Okay, based on the, I guess, the increase in enthalpy. Yeah, you base it on the enthalpy increase. Okay. What? So let's check out what's going on first. We have an energy input here. We multiply it by the efficiency, divide it by the mass flow rate. Okay. Sure. This assumes like yeah, we are not exactly increasing the temperature just yet. It looks a bit confusing to me. Okay. Alright, so Yeah, it does this thing called okay, there's some dependency here, and it's a property package, as you can see. Calculate equilibrium, and then based on that you get a calculated temperature, and done. That is based on the property package. So it looks like, alright, it looks like all of these will be somewhat dependent on a property package of sorts, which does make sense. I just don't quite know why why the calculation algorithm is like that. There's an energy flow in for sure. Some of it's supposed to increase the heat of the system, okay, and some of it is supposed to sort of supposed to what do you call that? Yeah, suppose part of it goes to increasing pressure, which is like work done on the system. Part of it is supposed to increase that internal energy, and of course this enthalpy equals to U plus PV kind of a thing. Maybe we want to check this algorithm here. It looks a bit funny to me, because yeah, if we are just putting in work plus Q, right, work plus Q, both of them should like, sort of increase the enthalpy, I think. Right, so yeah, beats me. Okay. Yeah, I rather just calculate the work done on this system first. Yeah, work done on this system. Yeah, the work done that used to increase the pressure, and the rest of it sort of is supposed to increase enthalpy as well, because enthalpy is the PV work plus internal energy. Yeah, I'll probably have to check this thing later on. I'll deal with it later. But okay, next thing we look at is this property package here. Let's see whether let's see whether we can do something. So pump power, we'll just use pump power as a baseline. Okay, just type out the dependencies. Okay, dependencies, and remember we always depend on interfaces. Okay, we have property package. Okay, so we give it a property package interface, and this property package will be implemented. Okay, it will have certain inputs and outputs. You need to select the property package, of course. Yeah, so remember that time we actually looked at property package, it was a huge mess of things. Let's go to property package, Thermodynamics, property packages. Yeah, we just look at property package.vb, and of course we'll have this very scary code that is 12,000 lines long. There's so many things it does. Okay, so we'll try to dissect it. Okay, I'll try to dissect it. Then hopefully we can tidy up the code as well. Yeah, you see how much we are actually trying to do here. So it's pretty ambitious. Okay, let's zoom out. Let's zoom out. Okay, zoom to fit. Control 1. Yeah. Woo. And now is a good time to actually do the focus mode. Okay. All right. Okay, property package. Okay, so forget everything on the left hand side. I just want to focus on property package now. What's the input of the property package? Inputs. Okay, outputs. I'll turn on the focus mode. I want to see what's going on here. Property package will have inputs and outputs. Okay, what's the input and output of a property package? Okay, well, look at this. There's sort of phases here. Liquid 1, liquid 2, liquid 3, aqueous, solid, mixture. So many phases, states, flash specifications, thermal property, package type, child seeder. Wow, so many. Flash method. Okay, so wow, there's a lot of inputs someone needs to give here. Okay, let's. Oh. Okay, so there are a few things here. Phase type, state. What am I supposed to do with this? Okay, this thing is definitely here to definitely difficult. Okay, let's do it this way. All right, property package. I'll have some implementations here. I will have a liquid property package and a solid mixed phase property package, and both of these should be interfaces. Let me think. Maybe I'll just say this is a dependency. Liquid property package, mix phase property package. So we'll segregate the property package into two parts. One is called liquid property package, one is called mixed phase property package. So we can actually simplify our way, because mixed phase will have gaseous phase, we'll have liquid mixture, and all of that. Okay, maybe I'll have a pure fluid property package. Yeah, I'll segregate all of this. Okay, what's a property package supposed to do? Inputs and outputs is okay. Yeah, I guess one of the things, regardless of the property package we are using, we'll need to actually look at the flash method. Okay, inputs will be flash method or calculation algorithm. Okay, this is the flash method over here. There's some nested loops and everything over here, and this will be a dependency of sorts. Okay, maybe I'll have a flash algorithm. Okay, this will be a dependency injection that will be put in here. Package type, you will need to tell what package type it is, but I'd rather put it over here. Input, here will be the package type. Okay, what's the output of a property package? Okay, outputs, you see that there are lots of functions being used. There's a lot of, and what I want the property package to express are just the functions. Flash algorithms. Okay, so I want it just to store flash algorithms. Let's see. The output here is not a data piece per se. I want it to output flash algorithms. Like flash algorithms. What are flash algorithms? Maybe I call it pH flash. Okay, calculates all variables, thermal variables based on pressure, enthalpy. Okay, so that's what pH flash is. PT flash, as so on and so forth. PS. Okay. Okay, just for example, I might change that later. It's just a lot to deal with. Okay. Now, let's try to make sense of what's going on here as far as we can. Okay, you see over here that there are so many methods. It's just method after method of calculation mode right here. AUX CPI, Opt CPI, Racket TC IJT. Yeah, I have no idea what all of these are. It's just I guess lots of calculation methods. 12,000 lines long worth. I have no idea why he wants to put it like that, but okay, looks like all of these are so-called concrete implementations of some methods and ways to actually print out forms. Okay, not a good way of designing, but yeah, I guess here it looks like it's storing lots of algorithms here. Okay, it's calculate overall props. You can see this is a method here used to calculate all the thermodynamic properties, calculate density, calculate liquid mixture properties. Okay, somehow all of these methods are just squeezed into this property package. Okay, I don't really want to look at this anymore. Okay, but at least we figure out what a property package is supposed to do. It's just there to hold. Let me try to put a function here. Okay, holds all methods for flash calculation. Okay, so that's how I want the property package to function. So you can see what our dependency tree looks like already. It's pretty long, getting longer and longer. Okay, I component, the dependencies, for example, IPump, you have a pump selector which in turn depends on a pump calculator. Pump calculator will then be implemented by several of these implementations like pump power. The dependencies will be property package. The property package will then be dependent on, well, yeah, these. The liquid property package, what's the package type, etc, etc. Okay. So how do we yeah, the liquid property package will input the package type, and of course yeah, this will implement the iProperty package. Yeah, let me see, implemented by. Okay, so and all of this here is supposed to implement iProperty package. So maybe we have Steam table, delete Steam table property package. Maybe a CoolProps property package. This one's CoolProps is a very simple library for thermodynamics, which will do all the PS flash, PH flash, everything for us. Okay, let me show you. Because CoolProps is one of the DWSim libraries, easier ones. CoolProps C library. Okay, so this is CoolProp. Okay, CoolProp is a C++ library, but it has a lot of wrappers such as C#. You can see a C# wrapper. It's a NuGet. It's done as a NuGet package. Okay. So yeah. So yeah, C# is over here. There's this package called sharp fluids, and then based on this you can actually calculate the temperature, pressure, everything from the libraries over here. All of these are already compiled for us with all of these. Yeah, we can do that later. So this is what the CoolProps thing does. Okay, if you want I think a good thing also to take a look at is yeah, pure fluid. maybe I'll just call this pure fluid property package. Yeah, so this is a pure fluid. It can be a full liquid or full gas, and maybe I have an ideal gas, okay, in case one wants to use air cooling of some sort. Ideal gas property package. Okay, there should be some ideal gas property packages in DWSim. Okay, let's see, ideal.vb. See, ideal.vb is here. It has a function for us. Yeah, it has a function for us. Again, I also don't know what they're trying to do. Is it calculate calculate overall props, calculate properties. Yeah. Okay, so this is an ideal gas property package. I do not know why there are liquid and aqueous and solid things in here. You should not have any of these here. Okay, this actually breaks one of the rules. Okay, ideal gas property package is not supposed to actually deal with liquids or aqueous or solids at all. If you take a look at the solid principles, okay, we do not ever want to implement interfaces that it doesn't use. So this is one example, I think. Okay, we have an ideal gas property package. I think this is ideal gas, if I'm not wrong. Okay, I could be wrong. But if an ideal gas property package is actually trying to deal with all these other phases, like solids and liquids, then all of these things should not be here at all. Okay. Unless this is, of course, an ideal mixture, which could be a liquid. Okay. Then I shall apologize for not apologize. Now, those words will not be very applicable in that case. Okay. Let's see, PRSV2. Where's the ideal? Okay, public class ideal. So this is an ideal gas class. I don't know why there are two ideal gas classes there. RAMix CPCV. Okay, 100 lines. Okay, this is a nice piece of code. So okay, so many models and packages here. So I probably won't take them all. Okay, this is the ideal property. Oh, this is Raoult's law. Okay, Raoult's law. This is a gas solubility kind of a function. So that's why. But yeah, okay. If there's a case that ideal gas property package is taking in this dealing with solids and everything, then it should not be there. That's not the way to do it. Okay, let's see whether we have an ideal gas property package. There's an interface here, which is nice, but I don't see it like used as much. I don't know, I could be wrong. Ideal gas. Alright, let's see. Okay, probably not here. Seawater, sour water. Okay. Okay, there's a CoolProps property package here as well. A Visual Basic Code. Okay. So yeah, what is this property package dependent on? It's dependent on system math, DWSim property packages. Right, it's yeah, this is how am I supposed to deal with this? Okay. This code is really hard to read. There's just so much going on. in one file. Let's see. How long has this been going on for? 40 minutes. Okay. All right. Well, I'll stop recording for now. Maybe take a break. Yeah. I'll see you next time. Bye bye.